Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about resistor color codes. In my hand I have a resistor, and on this resistor you're going to see 4 bands of color. Those bands of color are used to indicate the numerical value of the resistor. So it gives us the measurement of resistance in ohms. So let's take a look at how we determine what those numerical values are. Typically you're going to see 4 bands of color, but I will talk about if you see more than that as well. And when you have these bands, the bands closest together are going to be read together, and the first band represents a number. And I'm going to talk about what number that particular color represents. The second band represents another number. So those 2 bands will give you a 2-digit number. Then the third band gives you the exponent to which 10 must be raised that multiplies to these numbers. So it'll be some power of 10, 10 squared, 10 to the 5th, and so on. The fourth band represents the tolerance. So that gives you an idea of what the range of that resistance value is. Let's take a look at what these different colors mean and how we can interpret those bands to get a value for our resistance. If you were to look up a table of the color codes, you might see something much more elaborate than what I'm showing here, but I'm going to try to hopefully simplify it for you. You're going to see a list of colors and their numerical values attached. So starting with black, which is 0, brown, which is 1, where I didn't have the appropriate color of pen, I just used black. I apologize for not having all of the colors. Red has a numerical value of 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. Each of these numbers, 0 to 9, can be used as part of the 2-digit number or as an exponent. Then there is gold and silver. With these colors, you will only see them on the 3rd or the 4th band. They will never be a numerical value, but they might be an exponent value, and the 4th band is tolerance. And sometimes you might not see a 4th band, and that has to do with tolerance. Let's take a look at an example so you can see how the colors tell us what the numerical value of that resistance is. So in our first example, we have purple, red, green. So the first 2 bands tell us the 2 digits. So purple or violet is 7. Red is a numerical value of 2. So our 2-digit number is 72. Then we multiply that by a power of 10. The power of 10 is determined by our 3rd band. The color of our 3rd band is green, so our power of 10 is 5. So those 3 bands tell us the numerical value of that resistor. We'll talk about tolerance in a minute, but what I want to do here is simplify this. Let's multiply these to get the actual value of this resistance in ohms. So 72 times 10 to the 5th. 10 to the 5th is 100,000. When I multiply that to 72, I will get 7,200,000 ohms. And when you work with that large of a value, you probably should be using the metric prefixes to replace some of those zeros. Just as a review, a kilo represents a value of 1,000, so a kilo ohm is 1,000 ohms. The prefix mega means 1 million, so a mega ohm represents 1,000,000 ohms. So we could write this as 7.2 mega ohms. We just simply divide by 1,000,000. Now let's take a look at that 4th band, which represents tolerance. So we don't look at the numerical value for red. On the 4th band, we look at the tolerance value for red, which is 2%. So that means that this is the value of that resistance but there's a range. There's a tolerance of 2%. So plus or minus 2%, which means that the actual value of this resistor could be 2% lower or 2% higher than this value. So what we want to do is find what 2% is, subtract it, and add it to get our lower and our upper limits of our range. In order to express a percent as a decimal, you have to divide by 100. So 2% divided by 100 is equal to 0.02. So when we want to find 2% of 7.2, we multiply by 0.02. That value is 0.144. So we're going to subtract 0.144 from this value to get the lower end or the lower range value. And then we're going to add 0.144 to this value to get the upper range. When I subtract 0.144 from 7.2, I get 7.056 mega ohms. And when I add it, I get 7.344 mega ohms. So the value of this resistor is anywhere between 7.056 mega ohms to 7.344 mega ohms, probably somewhere closer to 7.2 mega ohms. Let's take a look at some more examples. If we were going to take a look at the value of this resistor, the color bands are orange, red, brown. I don't have brown, so it's drawn in black, but I'm just going to write the word brown. And then the fourth band is gold. Again, I don't have a gold pen to show that. In order to find the value of this resistor, these two colors tell me the numerical values. So orange is 3, red is 2, and then the third band, brown, tells me the power of 10. So brown represents 1, so it's 10 to the 1 power. So the value of the resistor is 32 times 10 to the power of 1 ohms. And the fourth band, which is gold, tells me the tolerance. For gold, the tolerance is 5%. 32 times 10 to the 1 is just 32 times 10, which is 320 ohms. And that's going to be the value of that resistor. I also want to find the range. So I'm going to find 5% of 320. In order to change a percent to a decimal, you divide by 100. So 5% is equivalent to 0.05. So in order to find 5% of 320, we multiply 320 by 0.05, and that value is 16. So that means that the resistor could be 16 less than 320 or 16 more than that. It's going to be within that range. If I subtract 16 from 320, I get 304 ohms. If I add 16 to 320, I get 336 ohms. So I know the value of that resistor is somewhere between 304 ohms and 336 ohms, probably closer to 320. Let's take a look at another example. In my next example, my first band is blue, my second band is green, my third band is silver, and I don't have a fourth band. So the way that I'm going to interpret that is I start with the blue and the green. Those are my numerical values. So blue is 6, green is 5, so it's going to be 65 times 10 to the power of. Silver gives me my power of 10, and the power of 10 is -2. So the value of the resistor is 65 times 10 to the -2 ohms. And because I don't have a fourth band, if I don't have a fourth band, the tolerance is 20%. So let's multiply this. When I multiply 65 times 10 to the -2, I'm going to get 0.65 ohms. And then I can find the range by finding 20% of this and subtracting it and adding it. 20% when I divide by 100 is equal to 0.20. So if I take this value and multiply by 20%, I multiply by 0.2, and that value will be 0.13. I can subtract it to find my lower value or my lower range, which is going to be 0.52 ohms. I can add it to get the upper range, so I'm going to get 0.78 ohms. So the value of this resistor is 0.65 ohms, but in reality, the range of values can be anywhere from 0.52 ohms to 0.78 ohms. Sometimes you might see a resistor that has 5 or 6 bands, And let's take a look at how you interpret the value in that case. In the next example, I actually have all of the colors that I want to represent with the true colors. So when you have 5 bands, this last band still represents tolerance. This second last band still represents the power of 10. But instead of having 2 digits for your number, you're going to have 3 digits. These 3 bands represent the 3 digits. So my first band is blue, which has a numerical value of 6. My second band is green, which has a numerical value of 5. My third band is red, which has a numerical value of 2. Now I multiply by my power of 10. My power of 10 will be this band here, which is black, which is 0. So that's going to give me the value of the resistance. My fifth band, which is violet, gives me the tolerance. Ten to the 0 is 1. So this is a value of 652 ohms for this particular resistor. And this is my tolerance. So in order to find the range, I'm going to find 0.1% of this value. I'm going to subtract it and I'm going to add it. 0.1% is equivalent to 0.001. I divide by 100 to get rid of my percent sign. And then in order to find 0.1% of 652, I multiply 652 by 0.001, and that gives me 0.652. So that means that the value of the resistor can be that much more or less than this amount. So I subtract that from 652 to get 651.348 ohms. I add it to 652 to get 652.652 ohms. In a case like this, because the tolerance is so small, it might not be necessary to even find that. You can rest assured that the value of that resistor is pretty close to 652 ohms. If you encounter a resistor that has 6 bands, so one more than this, the first 3 represent the number. The next one represents the power of 10. The 5th band represents the tolerance. And the 6th band is going to represent a temperature coefficient. So on your color code chart, you're going to see another column that has those temperature coefficients for the various colors. But typically, you're going to see resistors with 4 bands.